Hey guys, it's Miss Middleton. We have a little bit we have a little bit of notes left. Sorry. It's the end of the day. Not making much sense anymore. Please go into your Unit 2 Functions and Formations of Other Celestial Bodies folder. Your notes are called Unit 2 Function and Formation of Other Celestial Bodies notes. So open those up. And when you open them up, they'll look like this, and you scroll on down to the very last page. Remember, all of this stuff is fair game for your test on Wednesday. So make sure that you know it. First thing first, let's talk about how Earth. So we started out with universe and we zoomed all the way in. Now we're at Earth and how it formed, okay? So the formation of Earth is a serendipitous essential qualities that allow for life. So all this means is that it's all by chance, or at least that's what scientists are saying from what we look at in the past. But the main things you need to be aware of is that our Earth was all molten initially, and that made the Earth break into layers. So there's layers inside of our Earth, and the formation of those layers we call the iron catastrophe. Okay, so we call that the iron catastrophe, where
classes in the 200.
Where it's not like you think of a catastrophe and you're like, oh my gosh, it was crazy. There was a volcano that erupted and then it wiped out a whole city and it was a catastrophe. All right. There were no people around, so you couldn't really have noticed. We as humans aren't aware of it. All it means is that during that time when Earth was all molten and being bombarded by other planets and other planetesimals, the baby planets, as Earth was forming like that and it was all molten, the heavier things, the iron, fell down into the middle of Earth. And then you have these less dense layers on the outside. All right. So the early Earth is a ball of liquid rock that separates into different layers due to different densities of the materials. So kind of a big deal. And that what we see is that there's a crust, which is less dense, mantle, which another way you might hear of it. So crust, you might hear lithospheres. Sometimes we'll use that. The mantle, we'll sometimes talk about the asthenosphere in there, and that's just a layer of the mantle that's squishy. You have the liquid outer core and the solid inner core. All right, the solid inner core is most dense. Both of these are made up of iron. One is liquid, one is solid. The solid one's in the middle. And just like if you've ever had a generator, or if you've ever worked on something that has a generator, you'll know that there's metal surrounded by metal that moves around it like that, kind of. And so that motion right there is what's happening inside Earth. You have this liquid iron moving around solid iron, and that's going to create a shield around us called the magnetosphere. All right. So a shield formed from the spinning core that blocks solar wind. Now, I want to remind you, if we didn't have our magnetosphere, we would look a lot like Mercury, which doesn't have an atmosphere, or like Mars, where there's not a lot of atmosphere there or surface water. So kind of a big deal. So I want to show you in the actual PowerPoint what our magnetosphere looks like, because it's kind of crazy looking right there. All right, so because our Earth broke into these layers, which this picture is on your notes, what you have is the magnetosphere forming. It kind of looks like Spider-Man to me. I'm not sure why, but this magnetosphere, as solar wind is coming and beating on this or tries to kill you, because remember, space is always trying to kill you, we have this awesome magnetosphere created by the layers within the Earth. Okay? Without it, we wouldn't have an atmosphere. Some things that it creates, let me just point out real quick. So the sun gives off pretty much electricity, and then those things hit our magnetosphere, They get carried up to the North and the South Pole, and that's what makes the Northern Lights or the Aurora Borealis. One of the things I want to see from my Earth science checklist. Okay, so pretty flippin' cool. All right, now let's talk about how the oceans formed, because the oceans are what helped us get an atmosphere like with oxygen in it. So the ocean, there's two theories on its origin. So either volcanoes erupted and like you can see Mount St. Helens eruption. So images, boom, there's a lot of like dust and clouds. Remember, clouds are mostly made up of water. So when a volcano erupts, it's adding water back up into the water cycle. So we might have gotten the oceans because volcanoes were active, but also we could have been hit by comets, which, remember, comets are pretty much space snowballs. They're dirty snowballs with space dust in them, but they're ice. Okay, so that ice could have hit Earth, melted, given us some water. Either way, there was a lot of iron early on, and those were removed. There was a lot of iron in the ocean, and they were removed and formed what we call the banded iron formations. So pretty much what happened is we had oxygen added into the atmosphere by something called stromatolites, which is a vocab word for sure. That oxygen interacted with the iron in the oceans, turned it into rust. The rust fell down to the bottom, and what we get are these crazy banded iron formations. So yeah, look at this. How crazy looking is this? We have pretty much a rock with layers of rust in it that's showing us that, hey, there was iron in the oceans, oxygen was added, and they turned into rust, and that rust sank down to the bottom of the ocean and became rock. It's crazy. It's crazy. So that's how scientists, they look at that and they say, oh, this is when oxygen was added into the atmosphere. Okay. Obviously, 3/4 of the Earth is water. That's why we call it the blue planet. Our first atmosphere was made out of carbon dioxide, ammonia, and water. That's very poisonous to people. We wouldn't have been able to survive initially. And our modern or our current atmosphere is made up of nitrogen and oxygen. Obviously, oxygen is the thing that we find important. Highlight this, underline it, do what you need to do to draw your attention to it. This will be on your test. I'm gonna fold it. All right, stromatolites. They're these weird bacteria blobs in the water, but they're a type of bacteria that actually does photosynthesis, which, remembers, takes carbon out of the air, puts oxygen back in the air. That's how we get oxygen. And yeah, that's how we get oxygen. These weird bacteria things is how oxygen was added to our atmosphere. So this vocab word, stromatolites, is definitely going to be on the test. Write it over and over and over again, or do what you need to do to remember it. But stromatolites are bacteria that make oxygen. And that is the end of our notes. Do the study guide.